So we're now going to look at pHs of strong acids. We're going to choose strong acids, or we're going to do strong acids because with weak acids it's far more difficult. If you remember strong acids, if we have HX, we are going to make H plus and we make X minus. If it was a weak acid, we'd have this equilibrium where we have some staying as the kind of the not dissociated and some as dissociated. Whereas in a strong acid, we get total dissociation. So if we've got 1 mole of this, we're going to get 1 mole of this. What we're going to do constantly in this is we will use our square brackets. So our concentration of Hx would be equal to our concentration of H plus, which would be equal to our concentration of X minus. We are going to be using square brackets constantly for this because it's the right it's the correct method of writing it. We should really write the state symbols, but it's pretty much a given that H plus is aqueous. So we don't, even though it's more correct, we don't have to do it. We don't have to write the state symbols. So the first thing we need to do when we're working out pHs, we need to know how many protons there are. So if we had 1 mole of HCl, we would then, when it's dissociated, would make 1 mole of H. So 1 mole of H pluses. If we had 1 mole of H2SO4, that would make 2 mole of H plus. It's really important that we realise that because a lot of people are going to drop marks because they don't realise this. With pH, we must always work in concentration. So sometimes they will give you things like this, then they will tell you a volume and you have to work out the concentrations. We have to use concentrations to work out pH. Sometimes they will give you this, so you work out the moles, and the volume, moles divided by volume gives the concentration. We must know the concentration. So if we know the concentration of H pluses, so the concentration of H plus is always what we're looking for when we're working with pH. Once you've found the concentration of the H plus ions, the protons, it's actually very, very easy. So what we do is we do minus log of the concentration of H pluses. So on your calculator, if you were to put minus log, then a number, it will effectively give you the pH. What I generally tend to do is I would do the log of the number and then remove the negative symbol. At A level, at GCSE, that would still work because we're only dealing with normal acids, so we're never going to get a minus pH. But all we have to do is the log of the H plus gives us the pH. We can actually also do it the other way around. So if we've got the pH of something, 10 to the power of minus pH, that gives us the concentration of H plus. So these two things we're going to be using all the time. And it's actually relatively simple. So if you look at the example, if we've got something with, let's say our concentration of, HNO3. So our concentration of HNO3 is equal to 0.5. Is that what it is? Yep. So we've got 0.5. So that means our concentration of H plus is also 0.5 because it's monoprotic. So we've got 0.5. So all we do is minus log of 0.5, and that gives us an answer of 0.30. So pH is also to 2 decimal places, but that we've worked out a pH when we have half or 0.5 molar of HNO3. If it was diprotic, you would just times it by 2. If it was triprotic, times it by 3. And if we wanted to work backwards, so in the other example, we've got HCl with a pH of 1.7. All we have to do, if we've got a pH of 1.7, we just do 10 to the power of minus 1.7, and that gives us 0.2. So that means our concentration of H plus for HCl is 0.2. And because it's monoprotic, it will be the same, so the concentration of HCl will be 0.2. So what we're going to do now is we're going to do the questions in section 2. So the tables, this table, and then try those questions. Right, off you go.